least for coming in the middle. Well, not so much for Python, I feel. But don't worry. All right, so let's review what we know. Okay. So all Java files are in. Also, all Java programs begin in classes, which start with public class, and then the name of the file that you're working with. And then any code that you execute begins here. In this magical line that we don't know the meaning of, called public static void main string args. And like I said, you're gonna have to take it from me that this is all black magic right now. And that's fine. Once you get this part, and this is just memorization as you just saw on your quiz, right? These curly braces essentially are like kind of ways of just organizing classes. Anything in between these two this outer curly brace and this closing curly brace says it's inside the class. Anything inside these curly braces says it's part of main. Okay, and we're going to be working in main. To print something out, we do system.out.println. And then anything between and then we can print out all sorts of things. We started out by printing out strings, where we could just put something in here and type, some words. And then the computer will spit it back out at us. Come on. Oh, are you kidding me? Combination output not in the world? This is all because I tried to update it beforehand. Should not have done that. Great. Well, time to go and do this the hard way. Fantastic. All right. Give me 1 second. CD teaching. Oh, CD intro. CD code. Okay. Oh, right. Okay. So all right, so we're inside the package called operators, so that's fine. All right, so in order to print anything out, we've got to do 2 steps, right? The first thing we do is java. So we first have to compile it, and then we have to run it. And then java. Now, of course, you're using an IDE, so that means that basically this should take, this basically is 1 step for you. All you have to do is just hit a button and it will execute for you. It says, could not, wrong name. Oh, how embarrassing. Maybe if I reboot it, it'll actually work. Okay. So this should print out hello. Give me 1 second. I'm sorry. I really don't know what happened there. I tried installing something for Java, and it just doesn't work right now. Okay. So run. Compilation output is not. Specify a output path in the command structure dialog. Okay. Classroom. Oh, are you? All right, obviously, I'll have to fix that later. So, new project. This window. New. And all right, so it was a problem with the project. Hooray. Not a problem with the actual IDE. All right, so going back to what we were doing, let's go ahead and restart our example. Java. Apologize for that. I'm sure that fills you all with vast amounts of confidence. All right, so, but sometimes even my tools break is kind of the point. All right, so to print something out, we put in system.out.println. Anything we want to print out goes between two quotation marks. And we can also, we can also print out various expressions such as 4 times 5, right? We learned about that, which produces 20. 4 times 5 plus 1, which would produce 21. And order of operations still applies. So if we do 4 plus 1 times 5, that'll be 1 times 5. That'll be 1 times 5. Oh, let's see. Let's do 2 times 5. So that'll be 10 plus 4 plus 1. Right? Order of operations still apply. The only thing that's really weird is that if we do division, right, where it does integer division, because we're dealing with integers and not whole numbers. So 4 plus 2 divided by 5 means that this becomes 0. So 4 plus 2 divided by 5, which is 0, plus 1. If we did 6, this would be 4 plus 1 plus 1. Because we basically throw out the remaining bits, the floating point parts of it. So, which leads us to different data types, right? We learned about int. So, int x is equal to some number. We can also create doubles, which are floating point numbers. We learned about, strings, which are essentially words. Okay, so those are the things that we learned yesterday. We also learned about scanner, how we can read things and write things. Okay, so we learned how to read things from the user using scanner. And we do that by saying scanner dot some scanner and then give it a name. System.in. And it's giving me an error saying it can't resolve that. And that's because that scanner has to be imported. So I let my IDE fix it for me. But in order to get this inside of our class, your IDE will most likely fix it for you. In order to use scanner, we do java.util.scanner. Okay. So that's what those were all the things we learned yesterday. And if I wanted to get some input from the user, string input is equal to scanner dot next line system dot out dot println, print the input. So now it's just waiting for me to put something in, and now it spat it back out at me. Okay. So, and there's, one of your assignments I gave you is on producing some ASCII art for there, and ASCII art, producing ASCII art can be fun, and I like it because it also introduces another point, which is methods essentially, which is a way to organize our code, right? So let's go ahead and let me show you that. Intro to methods. So here, I'm going to go ahead and show you. So public static void main is the primary method that we work with stuff. And it's all sorts of various black magic with things that you don't understand. Yeah, it's public. Okay, so we can understand that word. Maybe it means that, you know, people can see it and stuff. And that's pretty much what it means. Everybody can see public. Everybody can use it. Or public methods like main. Static, that's just a weird name, but essentially means it's not tied to an object, so I've just replaced a mystery with another mystery. Okay, so great that. Void, we don't know. I mean, that like sounds like some kind of Zen Buddhist thing. But it has to do with what gets returned. And we'll go into that. But for right now, let's go ahead and just focus on how we would write our own methods by giving you kind of an example. And I did this in Python, but didn't have the chance to do this in Java. So let's say I wanted to draw a rocket ship, just out of ASCII art. Basic stuff. And so I'm going to start by drawing the cone of this rocket ship. Now, you may notice that I put 2 slashes there, and remember that's because I need an escape sequence to draw the backslash, the other backslash. Okay, so I do 2 backslashes to produce 1 because it's used to do, the backslash is used to do special commands. Okay, oops, line it up a bit better like that. So there we go, and this is kind of why using a monospaced font is important. So I've got that part done, I run it. Oh, it's not running the right thing. So here, now I'm running it, so, oh, a bit jagged. There we go. So now run it again. There we go. All right, now let's start by like building like kind of like, you know, a body for it, a bunch of squares. System.out.println yeah, 6. So put a small divider over there, right? And then we'll make a box. Sorry, then we'll make a bit of a box going down using the pipe character over here, right? So that's kind of the vertical bar character that you never seem to use unless you're in computer science. Okay. And of course, you know, I'm lazy actually, so you should realize that at this point it should be quicker for me to just do this, right? Copy, Control-C, Control-V, paste, right? And then if I want to draw a bunch of these things, right? Then I can just paste them together like this, right? And then to do this, I kind of want, and then I can repeat this again to kind of give a, let's see, to give it a like a, you know, a jet engine kind of feel out of that. So I need another barrier over there, I feel, and then I need kind of let's see, maybe I can put in like some kind of yeah, kind of maybe a just bar showing that it's, you know, launching into space or something like that. That's not really going to work out for me though, but let's go ahead and run this. So we've got a basic kind of rocket going into space, nothing too fancy there. But suppose, you know, that this is for some reason my job from a sadistic boss, okay? And he's like, well, that rocket looks great, but I want something bigger. So I copy this, right? And then, so I do make it bigger, and didn't do that right. So got to copy this, Control V. There we go. More, right? So now I've made it bigger, right? Not sure really how big I've made it. It's pretty big though, right? But all I'm doing is copying and pasting the same line over and over again, right? Right, I'm calling the same commands over and over again. So what we can do is that we can organize a program into new commands. So we can divide this because really what we've got here is essentially we've got the top of the rocket, okay? We've got the body of the rocket, and then we've got the bottom. And it turns out that the top and the body are pretty much the same. The top and the bottom are pretty much the same. So we can organize it by dividing it into our own methods. Methods are our way, we can write methods other than main to basically add new commands to the Java programming language. And they all start the same way, public static void. Okay, that's how I declare a method. Or what we call a void method, which are just methods essentially that will only print things. So let's call this print top, and this will print the top of our ship. And we use these parentheses to indicate that it's a command, right? Parentheses indicate that something's a command, a function. Just like in math, how you could tell the difference between something was a function or not, right? The way we knew that f was a function in math was that f would always have parentheses, right? It would sometimes have stuff inside of it, like f of x, assuming we can find the x key, right? But instead we would do, and whereas x itself would not have any parentheses.
So we're putting a new hash star in the public static void print top.
We're printing, well, sorry?
What's the print top one?
It's going to, what we're going to do is that we're going to take these three lines over here. I'm going to cut them, Control X, put them in here into print top. And now what will happen is whenever I call print top, it will execute those three lines. So just to show you, I'm going to comment out the rest of the code. So I'm going to comment out the rest of the code. So remember, a slash star, what this does, it makes anything between a slash star and a star slash, the computer will ignore. So now this will only print the top. Boom, it just does it. So it looks at this and it says print top. That's a command. What command are those commands? Let me go to print top to find out. And then executes those commands and then it returns to where it was. And you can call this a bunch of times now, right? Let's call it 3 times, and we've got essentially that going off there. So now, as you can see, this will start cleaning up by saying we can draw this. So let's go ahead and do public static void draw box. We can paste that part in. And now we can do, actually, let's be consistent. I called the first one print top, so this will be called print box. Print box, print box, print box, and then I'll follow it off with a print top. And now if we run this, we get something that looks pretty similar to that. And now what's cool about this is that if I want to change stuff, like add a little X in the middle of every box, if I didn't have methods, I'd have to go in and change all 5 or 20 of these. Give me a second. But now I can just like put an XX over here, like this in them. And then if, say, I want them to be separated by equal signs rather than, you know, minus signs, all I have to do now is change one method and it changes all of them, right? So I've changed, whereas if the way I was doing it before, I'd have to go and print it, I'd change everything. You had a question? Okay. So we can organize, so when we work on individual small problems, we can also put them into methods. So that makes that kind of useful, right? So, but also we can do things like what we had from what you get with math programs. Right? I mentioned that basically that that functions, they're denoted by the fact that they have parentheses, but this one didn't have any parameters in it, like f of x, right? Right? Well, we can add like stuff like that, and I could do something like this. public static void print double. Where it can, and what I can do is that I can tell it to take in some parameters, like give it just for, let's see. So I can tell it print double, where if I give it a number, like say some integer x, we don't know what that number is until we're given it, right? I'm going to system.println twice that number. Makes sense? So let's see that in action. I'll print it at the bottom. Print double. So if I put in 10, I'm setting x in that, giving x the value of 10 in that function. It'll print out 20. So we can do that. We'll get in more into that later. But when we go over functions properly. But functions are useful for, I wanted to make sure I addressed it here, and because they're useful tools to basically organize your programs. Okay? So, but for right now, you're probably not going to need them for the basic stuff that we're doing today. So today's exercises will involve if-else statements. So there will be 3 small exercises. One will test your ability to do modular arithmetic. Another will test your ability to do, to just do basic mathematics conversions. And another will test your ability to apply what we learned about if-else statements. And then finally, I have another assignment which is bigger, and I don't expect to get to it yet, which will bring everything we've learned together, and it will be, and that's my date formatting or blame the pope assignment. So let's go ahead and learn about if-else statements. So first thing before we learn about if-else statements is that we want to, let's go, I'll be boring for the people who are already in Python and use basically the same example. So let's see. Is this a big word? Big string. Right? So let's make a very basic kind of program. It's going to ask the user to input a public static void main. It's going to ask the user to input a string. And I'm going to tell them whether or not it's a big string, right? So let's just begin that, right? Scanner keyboard. I'm just going to shorten it to KB to let me know that I'm taking a scanner and it's representing input from the keyboard. It's equal to a new scanner, right? This is how we create new, and right, there's 2 types of values in Java. You've got your objects and your primitives. Primitives are stuff like doubles and ints, and they represent data, whereas objects represent more complicated things that can do stuff, like read things. System.in, this just simply says I'm scanning from system.in. We'll learn later in the semester that we can scan from other stuff. KB. So here, I'm going to give us some instructions. So system.println please enter a word, a string, or let's be even more clear, some text. So, and then I'll print out system.out.println you entered, and then plus. But then what we need, well, first we have to actually read it from the user. So string input is equal to kb.next line to read from the user, to read a single line of text from the user. So I'll read everything they type up until they hit the enter key. So you entered plus input. So right. Hello there. So suppose you wanted to say whether or not that was what you considered a big string or not. And let's say a big string is made up of more than 10 characters. Well, we can use a basic statement to figure that out. Something we call an if-else statement, right? So if I told you in the first lecture, there's basically 3 things we can do with computers. Programs do only 3 things. Execute commands, make basic decisions. If this, do that, otherwise do that. Okay? And repeat things. So, the way an if statement works is that it says if, and then you put in a Boolean expression here, which we'll go into. It's actually, I kind of teach things in reverse because Boolean expressions are easy to understand how they work. So if the so let's say if the input is the input.length, so that input.length will tell me how big that string is. So if I put in something like hello, it will tell me it's 5 characters big. So if it's bigger than 10, and notice how it has curly braces as well. So system.println, that is a big string. So if I enter some text, so here I created a scanner. It says please enter some text. We got to this line. We're at line 11 right now. It's waiting for me to take in some text. Please enter some text. Hello, comma, world, exclamation point, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, more than 10. So it says you entered hello world. If the input is greater than 10, it tells me you entered a big string. Awesome. Nothing too much more than that. Say instead I run this and I just enter ABC. It just says I entered ABC. The stuff inside the if statement in that case doesn't execute because the length wasn't greater than 10. Right? So, now ifs can always have something attached to them called an else. It's completely optional, but you almost always see them together. And it makes a lot of sense. So an else block executes if the if block it's attached to doesn't. So that is not a big string. So now if we run this and if we enter hello, how are you? Right, that's a big string. So if the input.length is greater than 10, it executes that as a big string. And because it's greater than 10, it's going to skip over the else block because it's one or the other. Sorry?
How do I put the greater than left and where are they?
They should be next to your M key. They're on the period and the comma on an English keyboard. So shift. So that is a big string. That is not a big string. So if I enter now ABC, that is not a big string.
How do you import the scanner again?
To import the scanner, you type this you put this at the top of your program. Import java.util.scanner.
The very top or underneath?
Very top.
Okay.
Not sure of where it goes in regards to packages. But if you haven't imported the scanner, right, there should be a light bulb or something that crops over there, and it will fix it for you. At least on NetBeans. As far as packagings go,
I actually put mine below the package and that works.
Okay.
Yeah.
There you go then.
Wait, let's see, that's a big
Okay. So if statements and else statements, right? And then anything that comes after the if and else statement that's outside of them will execute. Like here, I'll just simply say done, right? So if I enter ABC, it will say that's not a big string and done, right? That makes sense. It happens outside of this if else decision tree, right? And how do you know that stuff is inside an if statement and stuff is inside an else statement? Well, that's what the curly braces are for. And we indent stuff to help. The indentation is optional in Java, but we keep it around just to make sure we can deal with it. So if input.length is greater than 10, big string. Oh, come on. Have I been recording? Oh, great. I haven't been capturing anything on this. Okay. So, anyway. So, there we go. So, we've got that. So, this is the program we've been writing. All right. So, we've got if input length is greater than 10, that's not a big string. Else, that's a big string. Otherwise, it's not a big string. Now, we can, of course, some decisions aren't simple as if-else things. Suppose we wanted to specify if strings were really big, like if they were greater than 15 characters. So if input.length is greater than 15 characters, we'll go system.out.println. That is a really big string. Okay. So now if I enter something, let's just bang on the keyboard now. Okay, something interesting happens. It says you entered whatever I just banged on the keyboard, more than 15 characters. It says that's a really big string. Then it says that's a big string. And then it skipped over the else statement because the if statement it's attached to executed, which may not make sense, but this, right? I mentioned that the else attaches to the if statement that it's connected to, right? So you've got this one if statement.
So if we're going to add another if statement,
then there's a couple ways we can go about this. One way is that we can just do a bunch of nested if-else statements, right? I can take this, right? So if it's greater than 15, I probably don't want to print out both it's a big string and it's a really big string, right? I can put them inside, I can nest them inside like this, right? So if it's greater than 15, do this. Otherwise, if it's greater than 10, do this. Otherwise, do that. However, if it gets more complicated, it's like, say I wanted to do something like this.
what do we do with it? So how do we cancel out the number 10 one if we're doing number 15 one?
This is one way to do it. So I'm showing you the bad way to do it first. But it works logically just fine. And suppose we wanted to define another thing saying that if the input.length was greater than 7, we'll say that's kind of a big string. Right? And this has just gotten hideously complicated looking, right? Right? So fortunately for us, there's a different way to do this. Instead, we can, if we've got a bunch of stuff that are interdependent, basically a bunch of conditions that all rely on each other, and we only want one to execute, we can arrange our statements like this, using else if as a single command. So let me go ahead and just organize this for you to see. And then I think yep. And then I just need to fix the indentation. Here we go. So now we have basically 4 conditions in one block, right? It's saying if the input length is greater than 15, that's a really big string. Otherwise, if it's not 15, right, that's what's going to get checked first, right? This gets checked first if it's greater than 15 because it does it in order. If it's greater than 15, that's a big string. Otherwise, if it's greater than 10, it's a big string. So really big to big. And then if it's greater than 7, it's kind of a big string. And then otherwise, if it's not any of those conditions, it's not a big string.
Right. I got my line.
You probably got your curly brace, have too many curly braces.
It only says going on one line, so I don't know.
I'll take a look at it, but but this code will go up online for you to take a look at. So please enter some text. You entered in, let's see, that was 50 million, which is kind of a big string, right? So it was not greater than 15, it was not greater than 7, but it was, sorry, 10, but it was greater than 7, so we executed this line. Make sense to everybody? All right. So what goes in here that triggers these statements are what we call Boolean statements, which is our other type of primitive that we have. Okay. Now, Booleans are named after this fella. It's named after this guy, George Boole, English mathematician who wrote a very pompous-sounding book called The Laws of Thought, which contains Boolean, talked about Boolean algebra, which worked on was basically you could work on it was math with true and false values, or values that were just zeros and ones, and since computers work with zeros and ones, you can immediately see how that's applicable to computers. You can essentially do math with computers with circuitry, just by creating a bunch of circuits that execute AND operations, OR operations, and NOT operations. So that's pretty nice. But so let's define what a Boolean is. So Boolean is a keyword in Java, a Boolean B, and it has two values, true or false, assuming you can spell either of them, okay, which apparently I can't. They're lowercase. In Python, they're uppercase, which tends to be a bit of a pain because I'm teaching both, so I'll sometimes forget. So false, and if you try to put something in there, else in there, it's not going to work. Booleans are only ever true or false. Okay, some languages don't even have built-in Booleans. Instead, they use numbers. They use zeros for false and non-zeros for anything that's true. Okay. And any kind of statement that uses a relational operator. So that's something like, let's say 1 greater than 2. That's going to produce a Boolean. Right? That's false. 1 is not greater than 2. Right? Okay, what about B is equal to 1 less than 2? Well, that's true. So we're going to print out true. Right? So these statements, less than, greater than, they give us, a Boolean value. Is 1 less than 1? No, it is not. What about less than or equal to 1? Now, my font just did something really funky there, where I put an equal sign in, and once I merged them together, it produced a less than or equal sign for you, so it makes it easy to read. But don't go looking for a less than or equal sign on your computer's screen. That's just a feature of the font I have running here. Makes it nice and easier to read. So 1 is less than or equal to 1. That's true. Let's run the console to show. Boom. Okay. Let's go ahead. In fact, I will go ahead and change my font for you guys. Just so I don't get too confusing. So let's go ahead and put it on source. There we go. There we go. Less than or equal to 1. Okay? So what kind of relational operations are there? Right? We have greater than, less than. We also have greater than or equal to, and we have less than or equal to. And then we have two things to tell whether or not things are then we have two things to check if we have two things for checking if things are equal or not equal, right? So if you remember, we had the assignment operator, right? Int x is equal to 5. And this meant we took 5 and stored it in x. We took the value on the right and we stored it on the left, in the variable on the left. Right? Remember that? And this is the assignment operator, not the equal, and it doesn't check for equality. So it's a very common mistake that people accidentally try to use the assignment operator to check stuff. But the assignment operator is a lot more powerful than that, right? We can do stuff with it like, say, like x is equal to 5, right? X is also equal to, let's see. But we can also do things that, well, it's an operator, so it means it can be put in an expression, so I can do things like this. X is equal to x plus 1. So this is important here. X is equal to x plus 1. So what's the value of x now? It's 6. Now why is it 6? Well, because we stored 5 in x, and then we have this expression. Now the assignment operation always occurs last, which is when. So what we do here is that says that x is, so it says that we're storing something in x. What are we storing? Well, we're storing the value of this expression, which is x, which is 5, plus 1. So this takes x's value and ups it by 1. If I did this, x is equal to x plus 7, we should get 12. Now this is a common enough operation that we actually have a shortcut for it. We can instead write it as x plus equals 7, which just simply says, which simply just translates to this: x is equal to x plus 7. It's a very common operation to do. Even more common operation to do it by 1. So we'll get into some tricky math with that later, but it's important to realize you can do that. You can re-reference a variable in terms of itself. So going back to here, though, that's the assignment operator. To check if two things are equal, like over here we had less than, to check if two things are equal, we use double equals, two equal signs to see if two things are equals. Is 1 equal to 1? That should be true. Is 1 equal to 3? That is false. So we have double equals to check if two things are equal. And then we have one more to check if things are not equal, which is very simply not, the exclamation point, which is used for not, the not symbol, and then equal. So 1 is not equal to 3. So those are the relationship operators we can do. We also have logical operators, which again, I'm going to use the same example I used earlier today because I liked it, right? What movie are we in? Okay, so let's say we are in a kind of a movie. We're kind of in a movie, and we want to know what kind of movie we're in. It's public static main, right? And we've got a friend complaining about two things. The first thing he's complaining about is Boolean. Let's see. Feeling dead. Let's set that equal to true to begin with. Okay? And our friend also complains that he is hungry for brains. Okay? So you guys, being the savvy movie watchers you are, you instantly recognize this is what kind of movie? A zombie movie, right? Right? If the guy is feeling dead and he's hungry for brains, then we are in a zombie movie, right? Those are the two conditions you need that basically describe a zombie. The guy's feeling kind of dead and he's hungry for brains. So if feeling dead equals true, so if feeling dead is true, and so we need to say it's two conditions, right? Two things together. So we use ampersands for those to represent and. So two ampersands together means and. So if feeling dead, and that's useful because these things are kind of like the and symbol, right? So two of them together mean a logical and. So if feeling dead is true and hungry for brains, system out there, print line, run, we're in a zombie movie. although we're never actually going to say zombie. Right? Zombie movies and TV shows never ever called the creatures zombies, right? Walking Dead always. I have no clue.
Because is it trying to imply that the zombie movies don't exist in the world that those take place in?
I mean, it would be very.
So it's trying to imply that everything's the same. Like in most of movies, everything is trying to imply that everything's the same except that zombie movies just don't exist. Because that's kind of hard to swallow.
Got a good point. But the point. Oh, and notice how I didn't have a equal equals true over here, right? It was just hungry for brains by itself. It evaluated to true. This is an expression just by itself. Things by themselves are expressions, so it evaluated to true. So true and true. For this to be true, for us to be in a zombie movie, both of the things had to be true. Okay? So now we're saying, though, let's say we are in a movie, though, and if we're feeling dead, if the friend's feeling dead, but he's hungry for brains, well, then we're not in a zombie movie, are we? Right? We're in some. So even though one of these things is true, even though he's hungry for brains, feeling dead isn't true. So this block of code doesn't execute. So let's set up a kind of condition for that. Else if feeling dead equals false, right? We're asking if it's false, and hungry for brains equals true. Okay. Sout run faster. We're in one of those weird cannibal movies. Right? Sout. Don't eat me. I'm a clown. I'll taste funny. Alright, so now, if this reevaluates here, right, feeling dead is false, hungry for brains is equal to true. So, feeling dead is equal to false, right? That evaluates to true, and hungry for brains equals true. That true. This is true here, this is true, so this evaluates to true, so both the sides are true, so the whole thing is true. Now, what's important here is that we can also, again, simplify this. We could remove the equals true from both of these. And furthermore, over here, we could put a not symbol in front of this. So we can say, if we're not feeling dead and hungry for brains. So what does this do? Well, feeling dead is false. So not feeling dead is what? True. So this side is true. And hungry for brains is true. So both sides of these evaluate and it's true. So with and conditions, what's important to remember is that it's only true if both sides of the expression are true. Okay? And that brings us to the or statement, which is the kind of the opposite statement. So project, so let's go with class, or statement. Let's go with raining. This is the classic kind of example. So say we want to know whether or not we want to bring our umbrella. Boolean is raining now is equal to false. Boolean is rain forecast equals true. So with an or statement, right, if the rain is forecast or if it's raining now, if either one of those are true or if both are true, right, I'd want to pack an umbrella, right? So if else. If it's raining right now, and then the or symbol, it uses two of those vertical bars we saw earlier. So those on an American keyboard is shift and then the key above the enter key, the backslash key. So if it's raining right now, or rain is forecast, and let's correct the spelling there. Rain is forecast. So if either of those are true, then the whole thing is true, right? It's the opposite of an and in some ways, right? An and is true if and only if both are if and only if both things are true. But ors are true if either of those things are true. An or is false if and only if both things are false. Bring an umbrella. Else, I can risk it. So here I've got is raining. Now, it's not raining now, but rain is forecast, so I'm going to bring an umbrella. Otherwise, I can risk it. If both of them are false, I'll say, oh, I don't need to bring an umbrella with me, right? But if it's raining now or if rain is forecast, I really would like to bring an umbrella. Okay. So that is pretty much all we need to know to get on to our exercises. So let's go ahead and take a look at our assignments. So the next assignment that you should work on is 3 small programs. Okay, 3 mini programs. You can do them all as a function in one file, or you can do them separately, right? So, for each of these assignments, you will write 3 small programs. You can create a file, or you can put them each in a different method, whatever. So, and there's just 3 small basic things. The first one is called 3sort, where I want you to write a program. It asks the user to enter 3 numbers, right? And remember, to read numbers from the user, you're going to want to use, let's see, right? Scanner, next line gives you strings, so to read integers, you'll want to use next int, right? To read numbers from the user, okay? So you have them enter 3 integers, which means you read 3 things with next int, and then the program will print the integers in sorted order. So if we enter the numbers 30, 10, and 20, your program will print 10, 20, 30, right? You can do this with just basic if-else logic, right? Next 2 come from your textbook, temperature. So you'll write a basic program that converts from Celsius to Fahrenheit. So what it's going to do is that it's going to ask the user for input. It's going to read a floating point value from the keyboard, so in other words, a double. And then we're going to calculate the result. So here's the formula, right? C times 9 divided by 5 plus 32. And be careful not to use integer division by accident, right? Right, 9 divided by 5, if you just do 9 divided by 5, that will give you 1, because you're doing integer division. So instead, you'll probably want to do something like 9.0 divided by 5.0, so that you're always working with doubles. And the third one, we'll test the modulo operator, and see if you can figure out how to use the modulo operator. So seconds to hours. So this one, you ask for the user to input seconds in integers, and what it's going to do is that it's going to calculate how many hours, minutes, and seconds can be made from seconds. So if I give you 5,000 seconds, you should be able to produce 1 hour, 23 minutes, and 20 seconds. The value I'm going to test is 3,665, which would be 1 hour, 1 minute, and 5 seconds. So that's what you'll work on, and I'll come across to help and I'll be around to help each of you with that.